Hello. In my recent videos, I've been showing C# design patterns, good techniques to solve a programming problem. In this video, I'm going to show an anti-pattern, a bad way that a problem is sometimes solved, and I'm going to show how to convert from that bad way to a good way. I call this particular anti-pattern procedural code in object-oriented code. Procedural code is code that has to be run in a specific order. For instance, think of giving someone driving directions. Turn right at the stoplight, drive down 3 blocks, take a left, turn right when you see the white building, and it's the third house on the right. If someone does those out of sequence or forgets to do one of those steps, they're not going to end up at the correct destination. And it's the same with programming. If you have a series of calculations that have to be done in a specific order, and someone skips one or does one in the wrong order, they won't get the correct results. To prevent this problem, we're going to use some object-oriented principles, in particular information hiding and encapsulation. For this example, we're going to do a pretend order entry program. Here we have a simple order class with an ID property, a customer property, and a list of line items, the items they're going to purchase. The customer class is just the ID, the name, and a boolean for whether or not the customer is a premium member, because the premium members don't pay shipping. The line item class has the inventory item and the quantity they're ordering. If they ordered 5 books, we'll have the book for the inventory item and 5 for the quantity. And the inventory item is what would kind of match up with our database of items, the ID, the item name, what tax category they're in. For this example, we'll have normal, medicine, food, and luxury items, which get taxed at different rates, the price, and the weight. Notice that all these classes just have the constructor and some properties. I call these dumb objects because there's no calculations or logic in any of these classes. For this demonstration, instead of having a front end for the program, I'm going to use a unit test project, and our unit test will act like our front end. Here's the unit test class, and we're going to test a simple order. First, we'll load up the inventory items from our pretend database. We have a Learn C# in 30 minutes book, a Learn F# in 31 minutes ebook, and Monster Energy drinks. And we have our customer here, Joe, who is not a premium customer. Then we have our code to create the order. Instead of using a user interface, we're just going to set some variables here in our unit test, and we create a new order for Joe. Joe orders 2 books, 1 ebook, and 10 energy drinks. Now we get to the procedural code. We need to calculate the tax, the shipping, the grand total. So we have our different tax rates here and set up some variables for the subtotal, the tax, and the shipping fee. Then we loop through each line item, get the subtotal for the line item, the price times the quantity, save that to our variable here, and add that to our subtotal variable. Then we look at what tax category the item is in and multiply the subtotal by the appropriate tax rate and add that to our tax variable. Then we check if the customer is a premium member. If they aren't, we need to calculate a shipping fee, which is the item's weight times the quantity times 50 cents. After we loop through all the items, then we create the grand total variable, which is the subtotal plus the tax plus the shipping fee. And then I have some assertions down here just to make sure that I get the correct values that I'm expecting. All of this code works, but it could cause a problem in the future. Let's say instead of this being unit test code, this is code for a Windows desktop program in WPF. And now your company decides you want to create a mobile app so your customers can order directly from their phone, or they want to create a website so people can order online. What you would probably do in your solution, over here I have the engine project with our business objects in it, and the test engine is our test project, which is our pretend user interface. What you would normally do in the solution is create another project that would be the phone app or the ASP.NET app, and it would use the engine project with your business objects. The problem is all of your calculating logic is in the user interface code and not in your business classes. So when you create these new front-end projects, you have to find the calculation logic in the other user interface project and copy and paste it into your new project. Then if you ever have a change in the future, let's say you start shipping overseas and you don't charge sales tax but you charge a higher shipping rate. Now you have to make the change in multiple places, and it's very easy to forget to make the change in one place. So what we want to do is move our logic into our business classes, and we actually want to move it to the lowest level of our business class. Here's a diagram of the class hierarchy. The connected to the UI section is where we currently have our logic, our calculations. It uses an order class, the order uses a customer class and a line item class, and the line item class uses the inventory item class. Right now, all of our calculations and logic are up here at the top. What we want to do is move that logic down as far as we can, and then just pull the results up to the next level where it's needed. The most obvious way to find code that can be moved down a level is to look wherever we have an equation, and everything on the right side of the equation is in a different class. So here we create the line item subtotal using values from line item item and the line item. So we're going to move this to a new property in our line item class. And since we're only reading this, we only need a get property. Here I've created a new property called subtotal in the line item class that multiplies the item price times the quantity. Now we can go back to our calculating code and replace this, where we were doing the calculation, with the property. Another thing we can move to a lower level is the tax rate. This is always based on the tax category of the item property, so we could move this down into the item class. In the inventory item class, I'll create a new property to return the tax rate based on the tax category. So now I have a tax rate property that looks at the tax category of the item and returns the appropriate sales tax rate. That lets us go back into our code here. So now instead of having the if and else ifs here, we can replace all of this code with a call that uses the line item tax rate, that new property we just created. And we'll delete those lines, which also means we can delete these variables where we had set up the tax rate before. And as we start cleaning up the code, we notice this line item subtotal variable, we can actually replace it with the line item subtotal property. And now we don't need that variable. Since this is a unit test, I'm going to rerun this, and it passes. So we know it's still calculating the same values down here. Next, we can take the calculation for the shipping, which uses the line item values, and make that into a property on line item. Then go back to our code here and replace this calculation with the property. Our code is smaller and cleaner now, but we can do even more. This loop here is going through the order line items, so we can probably move all of this into our order class. So let's go into order and create some new get-only properties for that. And now I have 3 new properties in the order class for the subtotal, the tax, and the shipping fee. The subtotal sums up all the subtotals from the line items. The tax calculates the tax for all these line items. And the shipping fee, if the customer is a premium member, returns 0. Otherwise, sums up all the shipping fees for the line items. Now we can go back to the code where we used to do our calculations, and we can actually delete all of these lines where we used to do the calculations. And the subtotal we can just call from the order, get that value from the property. The same with the tax. And the same with the shipping fee. And if we run the unit test again, it's still green, still calculates the correct values. And if we look here, we see the subtotal is only used in a couple of places. We can actually replace that with the order subtotal. The same with the tax variable. And the same with the shipping fee. And now we no longer need these variables. And if we look here for our total, this is using properties from the order, so we can actually make this another read-only property on the order class. Then go back to the code where we were doing our calculations. Replace that with the order total. This variable is no longer used anywhere, so we can delete it. And let's run our test. Still green. So now all that procedural code that we used to have here is gone. It's all in our order class or our line item class or our inventory class, and it's available for us as values to read from those business objects. Plus, if someone ever creates another project using our business objects, all of the rules for calculating the tax and the shipping fee are right here in the business object. It makes it so much easier to work with, so much easier to make changes. People don't forget things because they can't forget things. They call the total here and it automatically calculates everything it needs. One of the great benefits of object-oriented programming is that you can have smart objects. Your objects know how to calculate values. They know what they're supposed to do. This makes it easier to reuse your objects, and it also makes your objects a lot easier to work with because now the logic is inside the object. You don't have to go looking all over the rest of your program, which could be tens of thousands or hundreds of thousands of lines long, to find the logic. It's where it belongs. If you have any questions or comments about this anti-pattern and how to fix it, please let me know. Thanks.